In this course section, we'll continue working on the app or the project we started in the last section, but now we're going to make some progress towards that final goal of having a demo application that allows us to start and stop and manage multiple timers. And therefore, in this section, we'll take another look at state management, but at more advanced state-related concepts. Specifically, we'll take a look at React's Context API, which is a useful feature for managing state across multiple components and even across the entire app. And we'll take a look at the useReducer hook. And of course, since this course is all about learning how to use TypeScript with React, we'll put a focus on how to use TypeScript with these features. Now for this section, I prepared an adjusted starting project. It's essentially the final project from the last section, but I moved those components we built in the last section into a new UI components subfolder, and I added some new components here. Now, these new components are fairly trivial. Most of them are almost empty because, of course, we will work on them in this section. The add timer component is a bit more complex, but in the end also not too complex. It just contains a form based on that custom form component we built, and then uses the custom inputs and the custom button to render a form, and it has that form submission logic where we tell TypeScript which shape the submitted data will have, and will then use this add timer component to really register a newly added timer so that it also does show up on the UI later. But we'll build all these things together throughout the section. The app component now is a pretty lean component where I just output the header above the main section where I have the add timer and timers component. And therefore, if you run this application, you'll see an app that looks something like this on the screen. Here I'm zoomed in quite a bit, so it will probably look more something like this. And we're now going to add all the logic together. Now let's start by exploring React's Context API. The idea behind that React feature is that it gets easier to manage cross-component state. For example, here in this app, it's the add timer component where we get the data for a new timer that should be created, but it's then the timers component where the timers should be output, and it's, for example, the header component where I want to be able to stop running timers. So it's multiple components that need to work together. And in situations like this, you can either lift the state up and, for example, manage all the state in the app component, since that component has access to all the different components that are interested in the state, or to keep that app component lean and not manage everything in there, you could use the Context API, or a third-party solution like Redux. But in this section, we'll use the Context API. For that, I'll add a new folder in this source folder in the project, and I'll name it store. The name is up to you, but that is a common convention for storing the files that are involved with the data management with help of the Context API. In that store folder, I'll add a single new file, which I'll name timerscontext.tsx. .tsx because we will output some JSX code in there. Now in this file, we should, as a first step, import the createContext function from React. This is a function that's executed to create a so-called context object, which we will need for managing that context, so that application-wide data. So createContext should be executed, and it will return a value that should be stored in a variable or constant. Here I use a constant called timersContext. The name is up to you, but I chose a name that starts with an uppercase character because we'll soon use this as a component. Or to be precise, we'll use a value that's stored in some property of that context object as a component soon. So that's how we create such a context. Now, this context thing is all about managing some data, some value that is needed in different parts of the app though. That's why create context needs one argument. It needs the initial value it should manage. We'll be able to change that value later, but it needs an initial value. But here I'll actually start with null as an initial value, because I will actually initialize and manage it in a different place later. However, I want to let TypeScript know which kind of data I'll eventually manage here. And that's why create context is a generic type, so that we can predefine the type of data we will eventually manage with it, even if it's initially null. So therefore, I'll define a new type here, and I'll name it timers state. That should be an object, and in that object, for this app, I want to have a is running Boolean value, so true or false, and I want to have a list of all the timers that have been added. For that, I'll actually add yet another type called timer, which describes a single timer, because timers should then be multiple timers, so an array of timers. A single timer should be made up of a name, which is of type string, and a duration, which should be a number. And then here we can set timers equal to timer array. So this timer's state in the end is the value that should be managed by this context later. However, this context object that we're in the end managing is not just made up of the main value that should be managed. Instead, it also contains methods that can later be called from different places in the app that should manipulate that value. Therefore, I'll add yet another type, which I'll name timers context value. And that should be my timer's state merged together with another object. And that object should now contain all the methods that will later eventually be callable to manipulate that state value that's managed with help of this context feature. And here, for this app, I want to have three methods that can be called. A add timer method, a start timers method, and a stop timers method. Now, add timer should be a function type, therefore, of course. All these properties should contain functions as values, but add timer should contain a function as a value that receives a parameter, which should be that timer data, which should have this shape here. So I expect to get this timer data here, and then this function shouldn't return anything. Start and stop timers should both be functions that don't take any arguments and that don't return anything. And it's now this timer's context value that's used here as a generic type for create context. So eventually that context will manage this object, which contains this state value that will be manipulated with help of these methods. But it's this overall merged object that will be accessible by different components in the application, so that different components can interact with that data and also call these methods to change the data. Now, of course, the initial value null is not in line with that generic type value, and therefore I'll actually convert this to a union type where null is the alternative value that could be managed by this context. And that's now the base setup for this context. Now, of course, this base setup here is not enough. With that, we got a timer's context, but we got no way of managing it, changing it, and really using it. Therefore, in React apps that use context, it is quite common to also create a special component function here that could be called timers context provider that will be responsible for managing this state that's stored in this context and for making that context available to all the components that are interested. For that, this timers context provider component should receive props, which are of a type that we can define here if we want to. Timers context provider props. And that should simply be a props object where we have the children prop, which is of type React Node, of course. And we worked with that a couple of times before in this course already. So React Node is of course a type and therefore can be imported as such by adding the type keyword in front of it. With that, that's my props type here. And therefore I can also destructure the children, of course. Now inside of this component function, I then want to return these children. So the content between the opening and closing tags of this timers context provider component. But these children should now be wrapped by yet another component. By a component that's part of this timers context object. So part of this context object that was created by createContext. And that's the timers context.provider component. So not timers context provider as my own component is named, but timers context dot provider. We're accessing a property called provider here, which is a valid React component. And it's now that component that's wrapped around these children. With that, I'm getting an error here though, because this built-in provider component wants a value prop. And that value prop must be of the type that we set for the context. So of this timers context value type here. Therefore, for the moment, I'll just add a new constant here. CTX could be the name. And that should be of type timers context value. And therefore, it should be an object that has a timers array, which initially can be empty. That has this isRunning prop, which maybe is false, let's say. And that then has all these methods. So here I want to have the add timer method, and I'll add the logic for that later. I want to have the start timers method, where we also add the logic later, and the stop timers method, like this. And it's now this CTX constant, so this value, that should be set as a value for this value prop on timers context provider. This error here is now just stemming from the fact that I'm not using timer data yet, but that will change in the future. So with that, we got our timers context provider component, and that can now be exported as a default here. With that, we can then go to the app component and wrap all the components that should eventually be able to interact with that centrally stored data with that component. In that case, that would be all the components here, so I'll just wrap all of them with my timers context provider component, which of course also must be imported. And with that, in theory, all these components would be able to tap into my context and, for example, read those values. But at the moment, they're not quite able to do that yet. Now, to access the context and, for example, consume the data stored in there, you have to go to the component that wants access, for example, the header component, and then use a special hook that's built into React. The useContext hook, which must be imported from React. The useContext hook then needs an argument, and that argument should be the context to which you want to reach out. So the context you want to access from inside this component, you could say. And for that, you need the timers context object that was created by createContext. So that return value of createContext is needed. So what you can do is you can add the export keyword here to make that available outside of this file. And then, for example, in the header component, you can use this timers context like this. This will give you access to that context object. And that is now either null or this timers context value. Now, it should actually never be null here, because we're wrapping the entire app with that provider component. And therefore, since in this timers context provider component, we do set a value to our context, the context actually never should be null when we try to access it here. But of course, TypeScript doesn't really understand all these connections in our app and how that all works. For TypeScript, this could be null here. Now, one way of working around that is to add an exclamation mark here to convince TypeScript that this will never be null. Therefore, now the type is inferred to be just timers context value and not potentially be null. An alternative would be to add a guard here and check if timers CTX is equal to null, and if it is, throw an error, because that really should not happen. So something went wrong here. And then thereafter, after this if check, TypeScript would understand that it's now not null anymore, that there is no scenario where this could be null. But adding this or this exclamation mark to every component where you want to access this is a bit annoying and easy to forget. That's why a common pattern, especially when working with TypeScript, is to create a custom hook. Because in React you can create custom hooks, you're not stuck with those built-in hooks. And therefore in the timers context TSX file, instead of exporting this timers context, we can instead export a function called useTimers context. And that would be a custom hook, because custom hook functions are in the end just regular functions that start with use in their name. And you can learn all about custom hooks and React in general in my React the Complete Guide course or similar guides. But in the end, the idea simply is that you have a function that's recognized by React as a hook function, which simply means a function that must only be called directly inside of a component function, or in another hook, but nowhere else. And here the idea with that custom hook simply is that we use the useContext hook inside of this custom hook. And therefore, of course, it must be imported from React. And then we get hold of the timers context here, like this. And we add this if check in this custom hook. So we check if timers CTX is equal to null. And if that's the case, we can throw an error. Timers context is null. That should not be the case. Something like this. And if we make it past this if check, we simply return this timers context. The advantage of that is that we can now go to the header component or wherever we need access to that context, and we can just call useTimers context and use that custom hook, which is now imported instead of timers context from the timers context TSX file. And we no longer need this useContext hook in the headers component, therefore. And the result of calling that hook will be that timers context object, which is now never null, because inside of that custom hook, we already performed that check, whether it's possibly null. So here, TypeScript knows that it's never null. And therefore now here, we could, for example, conditionally render stop timers if the timers are currently running, or start timers if they're not running. And we can do that by reaching out to timers context and taking a look at the isRunning property. And if it's true, that means that the timers are running, so that we want to output stop timers. Otherwise, we want to output start timers. At the moment, of course, we don't really have a way of changing that isRunning property yet, but that will come later. Nonetheless, if we save that and we take a look at our running app, you should see that it says start timers here. And if I, for example, go to my timers context TSX file and I change the initial isRunning value from false to true, you will see that if you save that, it instead says stop timers. So accessing the context value with help of that custom hook does work. So now that we got the context set up and we're able to work with that context, it's time to make it interactive. And as you might know, one common choice for making the context dynamic and interactive and for being able to change those values is to simply use state here in the timers context provider. So the default use state hook that's built into React. We could then manage the timers state, so an array of timers with use state, and also the isRunning state. And that would be a perfectly fine approach, but this section here is not just about working with React's context API, but also about working with its useReducer hook. Another hook built into React, which, just like useState, is also about managing some state, though you typically use that hook if the state is a bit more complex and there are potentially multiple triggers that could change that state. Ultimately, you can go for whichever hook you like though. But here we'll use this useReducer hook, and for that, of course, you must import it from React. And this useReducer hook then typically wants two arguments to work correctly. It wants a so-called reducer function, I'll get back to that in a second, and the initial state that should be managed by that hook. Now I will actually start with the initial state, because that should in the end be the timers and isRunning state. These methods are not data that should change. Instead, these should be methods that do change the data, but the functions themselves should not change. So it's in the end just timers and isRunning. That's the data that should be changed in this component. Now, if we scroll up in this file, we already do have this timers state type here, which holds exactly that state that should be changed, so that data that should be changed. Therefore, what we can do here, below that type definition, for example, we can create a new constant or variable called initial state, which should be of type timers state. So it should have a isRunning property, which initially is maybe true, let's say, and a timers property, which initially could be an empty array. But eventually it will hold a bunch of timers, not some random data. Instead, timers which have this shape. And it's now this initial state constant that I'll use as a value, as a second argument for useReducer. So that's how we can set an initial state. Next, let's tackle that reducer, because that's a bit more complex. So what's this reducer here? Well, that should be a function that's then automatically executed by React whenever we dispatch a new action. And we'll be able to dispatch such an action with help of the return value of useReducer. Because useReducer does return a value. To be precise, it returns an array, which we can therefore destructure with array destructuring, which has exactly two elements. The first element is the current state managed by useReducer. So we could name this timers state. The second element is a dispatch function, which we can therefore call dispatch, which allows us to trigger a state change. Because the idea with useReducer is that we can send messages, you could say, that will lead to the generation of a new state. The component function to which useReducer belongs will then be executed again, and the new state will be made available through this timer's state constant here. So through that first element of that array that's returned by useReducer. And it's this reducer function that will be responsible for generating the new state. It is a function that will be executed by React whenever a new message is sent, a new action is dispatched, and its job is to then produce a new state. Therefore here, outside of the timer's context provider function, I'll add a new function, which I'll call timer's reducer. The name is totally up to you though. And it's this timer's reducer that should be used as a first argument here for useReducer. And it's important that you don't execute the function here, instead you just point at it. Now this timer's reducer function must be a function that receives two parameters, a state and an action. Because as I mentioned, it's React that will be executing this function eventually. And React will give you the current state before the latest action was processed and the action that was dispatched. And it's then your job inside of that function to define some code that will handle different actions appropriately and change that state appropriately, or produce a new state appropriately, to be precise. Now, the end goal of timer's reducer therefore is to return a new timer's state. So that should be the return value here. Because that is the state, the shape of the state that we're managing with that reducer. The initial state is of type timer's state, and therefore the reducer that's responsible for generating a new state, of course, also should create an object of that same shape. Therefore, this incoming state here, which represents the old state before it was updated, should also be of type timer's state. Because that's our initial state, so before the reducer was executed for the first time, and then it continues producing new states of that shape, so it will always be of that shape. And that leaves us with just one question. What's the type of this action here? Well, that's generally up to you, because as mentioned, this action will be the message you're sending with help of dispatch. And you're, for example, doing that inside of add timer. Here we could dispatch an action that could be a string, which says add timer, or add timer like this. It could be a number. It's really up to you which shape and form that action should have. But it is quite common to work with action objects, where you have some property that uniquely identifies the different actions, and then potentially some extra data that might belong to an action. So therefore we could add a type action here, which is an object type, where we have a type property that could be of type string. And then we could set this as the type for our action here. With that, we then have to make sure that when we dispatch an action, we dispatch such an object with a type property where the type is some string. Now, typically, you don't want to be that flexible though. You don't want to allow all strings. Instead, you typically just have a couple of scenarios which you want to handle, a couple of different actions, and every action should therefore have one clearly defined identifier. So therefore, that's a great use case here for literal types used in conjunction with union types. For example, the type here could be add timer, or start timers, or stop timers. because these in the end are the three kind of methods I have here, and therefore in the end the three kind of actions I want to dispatch. So therefore here in add timer, I would dispatch an add timer action. In start timers, it would be start timers. And in stop timers, it would be an object where the type is set to stop timers. And we'll take care about the timer data later. So with that, we get this action object, which contains information regarding which state change is expected. We're getting the old state, and now the next step is to produce a fitting new state. So let's start producing some state here. And for that, you typically add if checks here to take a look at this incoming action. And here you then take a look at the type property in our case, and you try to find out which kind of action it is. For example, it could be start timers. In that case, we want to return a new state object, which must have this timers state here. For that, I'll start by copying in the old state so that we don't lose any data that we're not changing here. Because here I only want to change one of the two properties that make up that state. I want to change the isRunning property and set it to true if the action is start timers. I don't care about the timers array here, that's why I'm copying in the old state, so that that old data is not getting lost when I return a new state. You should not manipulate the state directly, so you should not do this. Instead, you should always produce a new state. Now we can of course then copy that and also look for the stop timers action type, and in that case set isRunning to false. And then of course we also have the case that action type is equal to add timer. And here I want to return a new object where I again copy the existing state, because now it's just the timers state I'm interested in. That's the state I now want to change. I don't care about the isRunning value here. And here the goal is to copy all my existing timers with help of the spread operator into a new array, but I'm copying the existing timers. And then I want to add a new timer, a new object, as a last element to that new array. Now that object must be of type timer, because that's how our state is defined here. It's an array of timers. And TypeScript understands that, which is why I'm getting autocompletion here for duration and name. But now the problem, of course, is that I'm missing the data that should be stored in those properties. My action object just has a type. It doesn't carry the data I need here. And that's something we'll have to change. So we must make sure that this action object can not just carry a type here, but also some extra payload, some extra data that might be needed for certain actions. Now, one way of achieving this would be to add a payload property here, but now it would be rather hard to type this. Because for one, it should be optional, because only the add timer action has a payload. The other actions don't come with any extra data attached to it. And then here, of course, the question is, what should be the type of that payload? Well, in the end, it should be an object with a name and duration. So we could set the payload here to this timer type we defined earlier, which is such an object with name and duration. The problem with that just is that if we add more actions with more types, this one type definition for payload might not be the right one for all the different action types. In addition, another problem we'll face here is that now we can access action.payload on all those actions. And on the other hand, on the one action where we need to access it, we have to convince TypeScript that this is not null by adding an exclamation mark. Because of course, for TypeScript, it could be null because the payload property is optional. So this way of setting up the action is not ideal. There's too much flexibility involved. A better way is to again work with discriminated unions and to create multiple action types for the different actions. For example, we would create a new start timers action, which is a simple object which has just one property, the type property, which is simply set to start timers. Nothing else. Then we have a stop timers action where the type is set to stop timers. And then we would have a add timer action, which is an object where the type is set to add timer and nothing else, and where we now also have a payload that's now not optional, so where we don't have a question mark, and which holds a value of type timer. And now the action, the general action type, would be a union type of timers action, stop timers action, and add timer action. With that, the result is comparable to what we had before. The action type can now be start timers, add timer, or stop timer, but TypeScript now is able to figure out that if the action type is start timers, we're in this object and we, for example, won't have any payload property. So if I try to access action.payload here, I'm getting an error. On the other hand, TypeScript also knows that here, if the action type is add timer, payload will always be defined because it's not optional in this object. Instead, it's required. Therefore, we can simply access action.payload.name and duration like this to extract that information from the dispatched action object. And that's how you should typically type your reducer function actions. Now, as you can see, I'm getting an error here that I'm not returning a value of type timers state, even though I would argue that I do. But the problem is that theoretically, we could dispatch some action that's not covered by our if statements, and therefore here at the very end of the reducer function, we can simply return the unchanged state. And with that, TypeScript is happy. So that's now the finished reducer with the improved actions. And with that, we can now go down to the timers context provider component again and dispatch those actions. For example here, for add timer, I want to attach a payload, which must be of type timer. Now conveniently, that's also the data type of this incoming timer data, so I can simply set timer data as a value for payload. For the other two actions, we don't need to add any payload, and therefore with that, we're done with setting up this dispatching code. But now, of course, we should make sure that the state that's managed by useReducer and that's exposed through that timers state constant here also ends up in the context again. So for example, timers should now be set to timers state.timers, and is running should be set to timers state is running, so that those stateful values end up in the context. With that, we now got dynamic state that can be changed. Now we should just make sure that we also somewhere in our application call one of these methods. And for that, I'll again go back to the header. There, we're currently extracting the isRunning prop, but on this button, we can now actually also add the onClick prop and make sure that we switch the timers from running to stopped and vice versa by simply pointing at timers context and then start timers or stop timers. Now, which of the two methods should be invoked, of course, depends on the current running state. So I actually want to check if timer's context is running is true. And if that's the case, I want to use timer's context stop timers as a value for onClick, so that this function will be invoked if the timers currently are running and the button is clicked. Otherwise, I'll point at timer's context start timers, so that this is the updated code for this header component. And with that, finally, if we go back to the application, we can click this button and you see that it toggles between start and stop. And that's now all controlled with the help of our context and useReducer that uses our reducer function. So therefore, now that we set up this context management and that we're using useReducer, let's finish this app for this section before we then really finish it in the next section by also dispatching those other actions, or to be precise, this one remaining action, the add timer action. And by then also outputting those timers that we did create. And therefore, it all starts in the add timer component. In there, we're getting that timer data from our form, and it's therefore in there where I want to dispatch this add timer action. And we can do that by using our custom use timers context hook, which is imported from the timers context TSX file. And then we can use object destructuring here to get hold of the add timer method. And all we have to do here in handle save timer is call add timer and pass the extracted data to it. Or almost. Because extracted data, of course, is an object with a name and a duration, but the duration here is of type string. It's not a number, and on the other hand, we do expect a number here in timer's context. Our timer wants a number for the duration, not a string. So we have to make sure that we convert that before we send that data to add timer. Hence, we can create a new object here and set the name to extracteddata.name, but set the duration to plus extracteddata.duration. And this simple plus here converts the string value, which contains a number but formatted as a string and of type string, to a valid number of type number. And that should be all that's needed to register a new timer. But of course, we now also need to output that registered timer. And for that, I'll go to that timer component here. Here, I expect to get some props where I get the name and duration of a timer, and then I want to output that name and duration here in that returned JSX code. So therefore, of course, we can add our timer props here, and that would be an object where the name is a string and the duration is a number. Now, of course, that's exactly the same shape we already defined here in timer's context for this timer. So what we can also do is export this timer type here, and then in the timer component, we can import timer from, and then we go up one level, dive into the store folder, and then the timer's context TSX file. And that will be a type. Now, to avoid name clashes with that function name, I'll then give this an alias of timer props and get rid of my custom type here. And with that, we can add timer props here as a type for props. And of course, then also use destructuring to get hold of the name and the duration. Therefore, we can now output the name here, and then below that in a paragraph, let's say, we could also output the duration. And we'll enhance this component later in the next section, but for the moment, that's it. Now we should go to the timers TSX file and there output a bunch of timer components, one for every registered timer. Therefore, of course, we need to know how many timers were registered, and we therefore need to reach out to our context with help of that custom useTimers context hook, which is imported from that appropriate file. And from there, we can get our timers like this. And then here in that unordered list, simply map through the timers, as we always do in React, and then get a single timer, and for every timer, output a list item where the key can be set to timer.name, which is not perfect because we could create multiple timers with the same name, but for this demo app here, it's good enough. And then inside of that list item, I want to output my timer component, which therefore also must be imported, onto which I spread this timer data. So the name and duration props. Well, and that should be it. With that, if you save that and reload, you should be able to add a new timer and click Add Timer and see it here. Now, at the moment, it's not running, but that's something we'll work on in the next section. But we can add all those timers, as you can see, and therefore we made a huge step forward, and most importantly, we learned how to use context and useReducer in conjunction with TypeScript.